diode logic is a method of implementing basic logic function like AND, OR, and NOT using diodes. It's one of the simplest and most cost-effective ways to design logic circuit. Today, we will focus specifically on the AND gate, which outputs high only when all inputs are high. Let's look at the circuit setup for diode logic AND gate. Each input is connected to the anode of the diode. The cathodes of all these diodes are connected together to form the output. A pull-down resistor is connected from the output to ground. This ensures the output is pulled low when required. Let's discuss how the circuit operates. When all inputs are high, all the diodes become fired bias. Current flows through the diodes and the output is pulled high. When any input is low, the corresponding diode becomes reverse bias and stops conducting. With no current flowing through, the pull-down resistor ensures the output remains low. This is how the AND logic implemented using diodes. Next, let's consider the voltage levels in the circuit. When a diode conducts, it introduces a forward voltage drop of 0.7 voltage for silicon diodes. This means the output voltage is slightly less than the input voltage by this amount. For example, if your input is 5 voltage, the output will be around 4.3 voltage. This is a key characteristic of diode-based logic circuit. There are several advantages to this approach. Simplicity. The circuit is easy to design and implement using just diodes and resistor. Second is low cost. The components are inexpensive and readily available, cost-effective for basic logic. However, there are also limitations. Voltage drop issue. The forward voltage drop of the diodes reduces the output voltage, which might not meet the required logic level of further stage. No amplification. The circuit cannot strengthen the signal. In fact, the output voltage might degrade. Limited application. Diode logic gates are suitable for only low-speed, small-scale application where voltage drop are acceptable. For high-speed or large-scale system, transistor-based logic is preferred.
For function of diode logic AND gate. First of all, based on the table, when both input are 0, the output also 0. As you can see, the LED doesn't turn on when both A and B are switched off. Then, when one of the input are 0, the output remains 0. In this case, A is 0 and B is 1. The LED doesn't turn on when B is switched on. For this case, A is 1 and B is 0, yet the output remains 0. The LED doesn't turn on when A is switched on. Last one, when both input are high, the output also high. As you can see, the LED turn on when both A and B are switched on.
Application of diode logic AND gate. There are many examples for diode logic AND gate application. Some of them are home appliances, alarm and security systems, irrigation system, and many more. For home appliances, we have printing device, which has two sensors, which is toner and paper tray, that leads to printing enable. When toner and paper tray is 0, V supply will go through D1 and D2, resulted in no output at printing enable. When toner is 0 and paper tray is 1, V supply will only go through D1 since D2 is reverse bias, resulted also in no output at printing enable. The opposite happens when toner is 1 and paper tray is 0, V supply will only go through D2 since D1 is reversed bias, resulted in no output at printing enable. However, when toner and paper tray is 1, V supply will go through printing enable since both D1 and D2 is reversed bias, resulted as an output for printing enable. Another example for diode logic and gate applications is alarm and security systems. For alarm and security systems, there are motion sensor and contact sensor as the diodes that will activate the alarms. When motion sensor and contact sensor is 0, V supply will go through D1 and D2, resulted as no output at alarm activates. When motion sensor is 1 and contact sensor is 0, V supply will only go through D2 since D1 is reverse bias, resulted in no output at alarm activates. However, when contact sensor is 1 and motion sensor is 0, V supply will only go through D1 instead of D2 because D2 is reverse bias, resulted also in no output at alarm activates. When contact sensor and motion sensor both sends out 1, V supply will go through alarm activate since D1 and D2 both are reverse bias, which activates the alarm. Thank you for watching our video presentation from Akmal, Yusof and Muhammad. Lifelong learning and goodbye.